Hello dear students. Today we'll be learning on angles of tangency. Let's start. The angle of tangency is the angle which is composed of the union of two rays. One of them is a tangent to the circle and the other contains a chord to the circle passing through the point of tangency. As you can see in this circle, here we have chord AB and tangent BD. They are meeting together at the point of tangency. So, where is the angle of tangency? Yes, good job. The angle of tangency is angle ABD. So, what's the relation? The measure of angle ABD is half the measure of arc ACB. Again, the measure of angle ABD is half the measure of arc ACB. Let's go to the examples. Example 1. In each of the following figures, calculate the measure of angle ABC. You will see that the measure of angle ABC equals half the measure of arc AB. Then it's half arc B is what? Arc AB is what? Arc AB is 360 minus 230 degrees. So the measure of angle ABC is half 130, which is 65 degrees. As you can see here, this angle is 230 degrees. So this arc, the big one, is 230 degrees. So AB is the rest of the degrees to complete the circle, which is 360. So this one is the 130 degrees. So let's move to number 2. In number 2, you will see that the measure of arc AB is equal to the measure of arc AD is equal to the measure of arc DB. Why is that? Because as you can see that chords AB, AD, and DB are equal in length. So each arc of these ones is equal to 360 divided by 3, which is 120 degrees. So the measure of angle ABC equals half the 120 degrees, which is 60 degrees. Now we'll go to theorem 5. What does theorem 5 say? Theorem 5 says the measure of the angle of tangency is equal to the measure of the inscribed angle subtended by the same arc. The measure of angle ABC is equal to the measure of arc AB, and also since the measure of angle D equals half the measure of arc AB, then as you can see from 1 and 2, angle ABC is equal to angle D. So the theorem says the measure of the angle of tangency is equal to the measure of the inscribed angle subtended by the same arc. As you can see that angle ADB is subtended by arc AB, and the same thing for angle ABC is subtended by arc AB. So they both are subtended from the same arc. That's why these two angles are equal. Angle ABC is equal to angle D. The corollary: the measure of the angle of tangency is half the measure of the central angle subtended by the same arc. If you can check this figure, you will see that BC is tangent to circle M, where AB is a chord of tangency. They are both meeting at the point of tangency, which is point B. Therefore, the measure of angle ABC is equal to the measure of angle D. And this is the theorem. The measure of angle D equals half the measure of angle AMB. This is another theorem. That's why the measure of angle ABC equals half the measure of angle AMB. Let's see example 2. In example 2, the question says, in each of the following figures, BC is a tangent to the circle. Find the value of the symbol used in measuring. The question is asking you to find the values of x and y. Let's go to question number 1. Here, x is angle of tangency, where angle D is an inscribed angle. So, x equals the measure of angle D equal 70 degrees. Because, as you can see, D and x, which is angle ABC, are subtended by the same arc AB. Let's go for y. You will see that the measure of arc AB equals to the measure of angle D. Then it's 2 times 70, which is 140 degrees. Then y equals 140. Let's move on to question 2. In question 2, AD is a diameter. Then, measure of angle ABD equals 90 degrees. Inscribed angle in a semicircle. Therefore, the measure of angle ADB equals 180 minus the sum of 90 and 30, because there are 3 interior angles in one triangle. Then it's 60 degrees. So, y equals the measure of angle ADB is 60. 2 inscribed angles subtended by arc AB. To find x, you will see that, yes, good job, x is equal to y. Why is that? X is angle of tangency, while y is an inscribed angle, and they both are subtended by arc AB. So, as long as y was equal to 60 degrees, so angle x equal 60 degrees. So x equal 60. Let's move on to an important note. The note says, the angle of tangency is supplementary to the drawn inscribed angle on the chord of the angle of tangency and in one side of it. What do you mean by supplementary? The sum is, yes, excellent, 180 degrees. So, angle ABC is supplementary to angle AEB. Let us say it again. Angle ABC is supplementary to angle AEB. Example 3. In this example, you will see that angle ABC is a triangle inscribed in a circle, where BD is a tangent to that circle at point B. So point B is the point of tangency, where x belong to segment AB and y belong to segment BC. Another given point that xy is parallel to BD. The question wants you to prove that AXYC is a cyclic quadrilateral. Let's see how do we prove this. Since BD is a tangent to circle at B and AB is a chord of tangency, therefore measure of angle DBA is equal to the measure of angle C. Since XY is parallel to DB in the givens, therefore measure of angle DBA is equal to measure of angle BXY, and measure of angle BXY is equal to measure of angle C. Since angle BXY is exterior from the quadrilateral XYCA, therefore XYCA or AXYC is a cyclic quadrilateral. Let's now go and check the converse of theorem 5. If a ray is drawn from one end of a chord of a circle so that the angle between this ray and the chord is equal in measure to the inscribed angle subtended by the chord in the alternate side, then this ray is a tangent to this circle. If we draw AD ray from one end of the chord AB in circle M, you will see that the measure of angle DAB equals the measure of angle C. Then AD is a tangent to circle M. Example number 4. In each of the following shapes, show that AD is a tangent to the circle passing through the vertices of triangle ABC. In question number 1, CA is equal to CB. This is given. Therefore, the measure of angle B equals the measure of angle CAB, which is equal how many degrees? Yes, 65 degrees. Then the measure of angle DAC equals 130 minus 65, which is 65 degrees, which is the same measure of angle B. Therefore, AD is a tangent to circle passes by or through the vertices of triangle ABC. If we check question 2, you will see that since ABC is a right triangle, and as you can see that AC is half the hypotenuse, which is BC, therefore the measure of angle B equal 30 degrees. Then the measure of angle C is 60 degrees, which is the same as the measure of angle DAB. As you can see that angle DAB is equal to angle C, then AD is a tangent to the circle passing through the vertices of triangle ABC. Let's check example 5. Triangle ABC is inscribed in a circle where AD is a tangent to the circle at point A, where X belongs to segment AB and Y belongs to segment AC, and XY is parallel to BC. The question is asking us to prove that AD is a tangent to the circle passing through the points A, X, and Y. you will see here that AD is a tangent. Then, if AD is a tangent, therefore the measure of angle DAB is equal to the measure of angle what? Yes, excellent, angle C. And let's call this remark number 1. From the second given that XY is parallel to BC and AC is the transversal, then measure of angle C is equal to measure of angle AYX. And this is the second remark. From 1 and 2, you will see that the measure of angle DAB is equal to the measure of angle AYX. Therefore, AD is a tangent to the circle passing through the points AXY. And now, we came to the end of our session. Thank you very much and good luck.